Okay. Okay, this is the Global Script programming live stream. Um, May. This is May the 4th, 2018. Um, at 4:53 p.m. Okay. So what I'm doing to back up is I've got, okay, so in Global Script, this is roughly what a typical expression might look like a function literal expression. But Global Script has basically no syntax that's attached to keywords. So the function literal, keyword, lambda. So this function literal is just considered a function application syntactically. This is just a special syntax for a function application. So lambda is a function. This is the first argument to the function, and then this is the second argument. Analyze is a function. It has one argument and a second argument. Case is a function. It has a first argument, a second argument, and then a third argument. And the second version of the Global Script syntax that I'm working on puts a comma there, well, there and there, which helps to make things a little bit easier to read. But it's not worth retrofitting it into this version. I can go back and fix that later. So, in order for that to work, this lambda function, which is really a library function, it's got an actual definition, which is GSI, no. Yeah, this is the definition of lambda. It takes a pattern, it takes a body, and it returns an argument, returns a function that takes x, applies the pattern to x, evaluates it, and then applies the body to the result. Pretty straightforward. And so lambda has this attribute, lambda-like, that marks it as a lambda-like function, a function that uses this alternative function application syntax. And so what I'm doing, I need to add a second attribute for the keyword where, because I'm trying to implement where clauses. I need to add a second attribute for where, and I've realized if a function has either of these attributes, you can't use it as a regular identifier. There's a way around that syntactically, but you can't. But you have to use a special syntax to override it. So I was thinking about this. You have to use a special syntax to get to it. And I realized that I'm going to have several cases of functions that have an alternative syntax. And then when I go to check for a regular function, I'm going to have to parse an identifier and then check each of these attributes. So what I decided to do was to combine them all into one attribute, which has a value that says, is it a regular function, which is the default value, or is it a lambda-like function, or does it act like where, or does it act like the else keyword that I haven't gotten to yet, or whatever it is. And so I've got I've got that refactor partway written. So I replaced the list of lambda-like attributes with this syntactic category attribute. This is something different. This tells you some lambda-like functions take 2 arguments, and some are like case and they take 3 arguments syntactically. And so else identifies the keywords that take 3 arguments. And then I've got lambda-like insert, which does it does a syntactic category insert with this special constant, syntactic category.lambda-like. And so I have to test this and make sure it works. And then the other thing I have to do is this returns a list of all the variables that have an explicitly declared syntactic category. And then this finds is supposed to find all of the variables where the syntactic category is lambda-like. And so then the parser will call that, and there's a particular place in the parser where we dynamically generate a list of alternatives, a list of branches for each of these lambda-like functions. So the parser value ends up looking like you might expect from Haskell or ML. We have a parser branch of the parser for each keyword, but we generate it dynamically. So it's easier to manage, and the user can define their own lambda-like functions if they have a pressing need to. The problem being, obviously, this is the first place that I've called filter in global scripts. And so I need to actually define filter now. So, and according to this error message, specifically I need to define the const case in filter. So I do that. This is how I do programming, especially in GlobalScript. And GlobalScript is designed to support this to where it'll give good error messages like this for the missing case expressions. GHC's runtime error messages for missing case expressions, they were pretty terrible the last time I seriously tried to program in Haskell, and I'm pretty sure they're still pretty terrible. In Haskell, I have a workaround where what I did the most recent time I had to use Haskell was I just wrote my own functions for each data type that just gave you the name of each constructor as a string. And then I just have a default on everything, and I turn off the overlapping patterns warning so it doesn't warn about the default when I don't need it, and then I just leave the default there all the time and let it catch things. So we can see that filter is now calling its first argument, which is expected. I tend to like to commit frequently. This is kind of a micro commit, but that happens a lot in GlobalScript. I tend to, because it's a lazy language and because it's very high order, I tend to bounce back and forth a lot between functions, and I try to commit every time I move from one function to another. So fill out the definition of filter, and then go up here, and we're going to run out of space on this line. So let me find that constructor name. And if it's lambda-like, return true. That's what we're looking for. Okay, so GlobalScript has views. So HSG to HS is now complaining that the function, it doesn't know this, but the function syntactic category lambda like is in scope, but there's no view with that name that's in scope. As far as the global script calculus is concerned, there's no such thing as a constructor. There's only a pair of a function and a view that happen to have the same name and the same type. So we're going to need to rebuild HSGS to HS now. So go ahead and do that. So we do that, we run all the tests for all of the whole global script language as far as HSGS to HS implements it. Undefined is a special case because we have to explicitly pass the location and the call stack into undefined so that it can generate a traceback. Okay. So we've added it to this global mapping, which maps global script functions onto Haskell functions. Now we need to actually add it to the Haskell module. And so HSGS to HS can translate most kinds of global script into Haskell. Like it can do all of this, but the one thing that it can't really do is constructor definitions. So the implementation does have a concept of a constructor. But you have to write the constructor and the view directly using Haskell. The views are kind of long, primarily because this GSBC conster view, I'm not really sure what I was thinking when I implemented it. I probably should go back and change it to return a GS value, because I think that's basically all we do it. That's all we use it for. Just return a GS value and have it do the GS lambda. Put it with something you can see. The GS lambda value, the GS BCR, whatever. Okay. Okay, so I typoed this. I cut and pasted something, or I don't remember. I'm tired. I meant to do this earlier this afternoon. The other option, of course, which isn't necessarily mutually exclusive, would be to go ahead and add something to HSGS to HS that will generate both of these for a constructor. So I can just say, hey, I need a constructor with this name that has this arity, and it'll know about it. This thing, GSBC conster view, oh shoot. It's got some horrible hack, but I forget what it is. So we are back to filter now. So we have two commits that we want to record, one of which is adding this view to the standard library. So we say add view syntactic category lambda like. And then, no, we don't want to record that because if we go back and look at that commit that we haven't pushed yet, that we're still working on, it actually this is this line that we're changing. So if we record a patch now, it'll depend on the patch that we're not done with, because it breaks tests that we're still working on. So instead, we want to go in and say darks amend, replace lambda-like attributes, like that. And then only once we've got that filled out enough that we can actually use it, then that we can actually, it won't break the test, then we want to commit it. We want to change the message to say, do not push. And then we can commit other commits, record other commits on top of it. So we've got the predicate returns true. And so in that case, we want to include X in the results and then call filter recursively. So we want to run the integration tests, and that should be, all of the syntactic categories should be lambda-likes because that's the only thing we support at this point. So the only other thing we need to do should be to add the nil case to filter. I'm just looking at this. This is buggy. This is, oh geez. This is like a short-circuiting version of zip, where if the first argument is nil, it'll return nil regardless of what the second argument is. Which is not symmetrical. GlobalScript zip is supposed to be lazy, where it'll return nil if either argument is nil. And that is how nested patterns like this work. But the problem is the way to implement zip using those would be to use like a tuple literal pattern. And I just don't feel like implementing tuple literal patterns just for like zip and map2 and map3 and a few cases like that. It is just not worth it for now. And then obviously filter p nil is nil, whatever the input list is. It's about the only thing you can do without returning a list that has bottoms in it. Actually, in GlobalScript, we're going to have like 3 kinds, and I'm going to distinguish between. I'm going to use it to distinguish between polymorphic functions that actually do need recursion on a particular type, and polymorphic functions that don't, and then of course polymorphic functions that use seek. I'll just use the kind system so you can declare your types and let the kinds be inferred. Or if you want to specify, if you want to get the stronger free theorems, then you can put a kind signature in. Syntactic category gets. Okay, so let me go ahead and commit that, record that change to filter. Okay, so this is the other tricky bit, is I want syntactic category gets to always return a value. I don't want it to return maybe. And so I could use like a from just, but quite frankly, analyze is going to do just fine for what we're trying to do here. Except that we have to say syntactic category dots I'm going to call it variable. Okay, so that's not in scope. So this is just a regular variable. No special handling, no special treatment. Like I said, it's the defaults. And so that is going to require us to recompile HSGS to HS. This test all obviously runs the full test suite for the whole implementation. I started with HSGS to HS. I'm using that to implement GSI, and then I'm using GSI primarily to implement GSIO, and then I'm going to use GSIO to re-implement HSGS to HS. And that's sort of the overall master plan for this project. So we go through HSGS to HS, GSI, GSIO, and then we go to GS to HS. And then this stuff is related to documentation for Acme and for the web. Rendering documentation for Acme and for the web. There's nothing in there because GS to HS is much more important. But right now, we can't really do anything. I'm pretty confident making changes without worrying about whether GSIO is still going to work because there's nothing in the GSIO directory, pretty much. And quite frankly, I'm comfortable if the tests pass without a missing case filled in, they will continue to pass after you fill it in. So this is another constant. You'll notice that the constructor names internally are missing this prefix. When I'm finally done, that is actually going to be a module name. So the declaration will look something like variable or lambda like or else like or something like that. Syntactic category is not ultimately going to be an enum like this. You'll be able to define your own syntactic categories, but that's much further down the road. For right now, I just want to get the predefined set working. So this is a structure literal, desugars to a structure literal, or compiles to a structure literal. And then we're exporting that to a module. But you could drop this in the middle of another module if you feel like it. But I have found that in general, qualifying constructors with the name of the type that they're constructors for is, if not necessary, at least a good idea. Okay, so here we have to go in and say case syntactic category dot variable, except that that's not going to work. I'm not going to write it that way just because it's stupid. So this is a little bit risky because I have to write code that I don't know is going to be directly tested by the integration test that I've got. This is the disadvantage of the integration test only strategy that I've adopted for GlobalScript. And so here you can see that the missing case, it prints out, it evaluates the scrutiny, if it needs to head normal form, and then it prints out as much information as it has. And so here we can just say, if it's there, return it. So here, like I was saying, I don't directly know that this is going to get exercised by the integration test that I've got. I know that it's going to skip over it, so I don't know that this is going to be exercised. This will be. I assume that this will be, because something's obviously calling lambda like get. And so the GSI integration test passed, so I'm going to run the whole test suite just to be sure. So I assume that this is actually going to get exercised. I don't know, but I'm pretty sure that this is the right code. So I can, yeah. Okay, don't want to record those because those are going to have to be amended into the patch that we're working on. Add this syntactic category variable or function or constant or whatever you want to call it. And I don't know, there's people that say that you have to be good at typing to be a programmer. I guess in that case I'm a bad programmer. Because I cannot type for anything. I could not type accurately and quickly to save my life. And so now we can go in here, change do not push. And this is going to be all the GlobalScript that I'm going to be able to do for today. Push it all, and then do something I have forgotten to do for a while, apparently, which is causing me problems on my Stack Overflow developer story because it thinks I haven't been working on GlobalScript. So yeah, it's going to push everything I've done since April 19th. Push that out to GitHub. The GitHub mirror is read-only. I don't know how to take pull requests and copy them back into Darks. But it's useful for various things, including, like I said, the Stack Overflow developer story. So we'll live with it. What this is all doing is adding an explicit type for quote-unquote documents. Documents are one of the two types of source files. So we have a file type, and now we have an explicit document type. And all the functions that manipulate documents, because there's like 4 or 5 passes to the compiler already just inside the interpreter. Those all take documents and all but the last pass return documents now. And so then when I add a where clause, I'm partway through adding support for where clauses. The functions that manipulate where clauses can take an expression and a where clause and return an expression in a where clause, which is going to be a lot more convenient. So this has been the Global Script Programming live stream for May the 4th, 2018. And I will see you all tomorrow.